let's work another related break problem. I have one here where we're going to actually be talking about the angle of elevation. This problem reads, a flag is raised while a person watches at a distance of 15 feet. The flag is being raised at a constant rate of 7 inches per second, assuming the flag starts out at the height that is equivalent to the onlooker's eye level. Find the rate of change of the angle of elevation from the onlooker's eye level to 10 seconds after the flag is being raised. So let's take a look at kind of what's going on here. I have a person, and he's looking at a flag being raised. So something like this, there's like a little flag right here being raised at, it says 7 inches per second. He is 15 feet away. And they want to know, let's see, he's 15 feet, 7 inches per second, assume blah, blah, blah. And they want to know what is the change in his eye level theta here. We're looking for that change. We're looking for d theta dt. But we do have, I'm going to call this y. We have dy dt is 7 inches per second. And then we have a, let's call this x. This is 15 feet. Well, we know we can't do feet and inches, so we have to multiply this by 12, and we are going to get, well, should be 180 inches. Okay, so this is all my given information from this problem with the kind of a rough sketch. So let's see if we can find d theta dt. All right, so I redrew our diagram here, got rid of the person and everything else. We have 180 inches here. We have y inches here. We know that the flag is being raised at 7 inches per second. We're looking for the change of this angle of elevation, or this d theta dt, after 10 seconds. So I need to write an equation that I can take a derivative of. So the first thing I think of is, well, you know what? I know my trig functions. I know that I can say tangent of theta is going to be my opposite over my adjacent, which is y over 180. In this case, I'm not going to write the units because this is an inch, and these are going to cancel out. So that's really just tangent of theta, which theta is an actual radian. So easy peasy. Now from here, I need to get theta by itself, so I can actually say theta equals arctangent of y over 108. All right. So that seems easy enough, right? That seems easy. So this whole thing itself represents a radian. It's an angle. It's a radian. So we kind of have to keep that in the back of our mind that this is a radian. All right, let's do some derivatives. So I'm going to do d theta dt, take the derivative of theta with respect to time, and this is going to be, well, the derivative of the middle, which is going to be 1 over 108 over, and then we're going to have 1 plus y over 180 squared, and then this is going to be dy dt. So we took the derivative of arctangent, and we're going to go from there. So let's simplify this out. All right, so let's simplify this. So I'm going to have 1 over 108 over, let's see, this is going to be 180 squared plus y squared over 180 squared. This goes to a 1, this goes to that. I still have my dy dt. This means just take the reciprocal of this. So I'm going to have 180 over 180 squared plus y squared dy d. Okay. And this is my d theta d. All right. So let's see. I don't know what y is. I don't know what y is, but that's okay, because I'm pretty sure I could figure it out because I know a little formula. Distance equals rate times time. I have a rate in the y direction, and so therefore my d is going to be my rate, 7 inches per second times 10 seconds. My seconds cancel, and that leaves me 70 inches. So my y, this is actually going to be my y, is 70 inches. Okay, so let's plug everything in. I've got 180 over 180 squared plus got my 70 squared. My dy dt is going to be 7 is just times 7. Then they're going to be, the units work out where it's going to be radians per second. And when I throw all of this into a calculator, I get 0.34 radians, and this is approximately radians per second. So that's how fast the angle of elevation is actually. So you don't have to take the arc tangent. You can just take the derivative of this side, derivative of this side, and go from there, and then just find your hypotenuse, which is going to be y squared, square root of y squared plus 180 squared, because then do this as tangent, you get secant goes over cosine squared, and all the math will still work out. But the key thing is to know that this is where the radian's coming from, because this arctan, this is a radian. That's where this radian comes from. All the other inches in that cancel out, and all that will be left will be radian per second. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.